The problem is to find the area bounded by the curve y equals x squared plus 1, the tangent line at the point 2, 5, and the coordinate axis. The curve given is a parabola defined by y equals x squared plus 1. To find the tangent line, we first need the slope, which is the derivative di divided by dx equals 2x. At the point where x equals 2, the slope m equals 2 times 2, which is 4. Using the point-slope form, the tangent line equation is y minus 5 equals 4 times x minus 2. Simplifying, y minus 5 equals 4x minus 8, so y equals 4x minus 3. Next, we find the intercepts of the tangent line to understand the bounded region. At x equals 0, y equals 4 times 0 minus 3, which is negative 3, so the line crosses below the x-axis. At y equals 0, setting 0 equals 4x minus 3 gives 4x equals 3, so x equals 3/4. Thus, the tangent line crosses the x-axis at the point 3/4, 0. The area we want is bounded by the coordinate axes, the parabola, and the tangent line. We calculate the area by integrating the difference between the parabola and the tangent line from 0 to 3/4. The integral of x squared plus 1 from 0 to 3/4 is the antiderivative x cubed divided by 3 plus x evaluated at these limits. Substituting, this equals the cube of 3/4 divided by 3 plus 3/4, which simplifies to 27/64 divided by 3 plus 3/4. Dividing 27/64 by 3 gives 27/192, and adding 3/4 gives 27/192 plus 3/4. Converting to a common denominator, 27/192 is 9/64, and 3/4 is 48/64, so their sum is 57/64. The integral of 4x minus 3 from 0 to 3/4 is the antiderivative 2x squared minus 3x evaluated at these limits. Substituting, this equals 2 times 3/4 squared minus 3 times 3/4, which is 2 times 9/16 minus 9/4. Simplifying, 2 times 9/16 is 18/16, and 9/4 is 18/8, so the difference is 18/16 minus 18/8. Converting to a common denominator, 18/16 is 9/8, so 9/8 minus 18/8 equals negative 9/8. The area is the difference of the two integrals, which is 57/64 minus negative 9/8, or 57/64 plus 9/8. First, the coordinate axes and the parabola are drawn. Differentiating gives a tangent slope of 4 at the point 2, 5. The tangent is extended to meet the x-axis at 3/4. The shaded region shows the difference between the parabola and tangent over this interval. Evaluating the two signed integrals gives the required area, 129/64 square units.